Machine learning is a method of analyzing data where a computer automatically learns using data and discovers the rules and patterns behind the data. In recent years, it has been viewed as critical to make predictions and judgments based on the results obtained through learning. Synonyms for machine learning include artificial intelligence, abbreviated as AI, and deep learning. Machine learning is one of the data analysis techniques to create artificial intelligence, and deep learning is said to be a typical analysis method of machine learning. AI is a broad concept and has no clear definition, but it can be viewed as artificially created intelligence. Artificial intelligence is created with rules behind a large amount of data. Machine learning is a way to discover these rules using computers. In addition, to discover the rules using a machine, the structure of the rules needs to be taught to the computer. One of the ways to structure rules is multilayering. An intermediate layer is provided between the input layer and the output layer, and the intermediate layer is further multilayered for learning. Due to added layers, complicated information can be addressed, which improves the accuracy of data analysis. The concept of deep learning is to find more accurate rules by multilayering the structure of rules. Deep learning is one of the methods of machine learning. The most critical point of machine learning is the accuracy of prediction. The focus is on whether they are predicted more accurately, not on whether the rules behind data are explained correctly. Prediction models may not be valid or convincing, because models are mechanically constructed with high prediction accuracy. On the other hand, it allows for making new discoveries that would not be possible to achieve with traditional statistical hypothesis testing data analysis. It also allows for the construction of highly accurate prediction models. There are three ways of machine learning for rules and patterns behind data. They are 1. Supervised learning, 2. Unsupervised learning, and 3. Reinforcement learning. In supervised learning, input data and output data are provided, and output data is estimated based on the input data. One way to analyze the relationship between input and output data is to perform regression analysis, which is a statistical technique, by combining all data mechanically. A typical example is a forecast of sales, based on factors such as weather, price, and promotions. Unsupervised learning is a method to find undiscovered patterns and structures behind data based on a set of input data. Compared with supervised learning, there are no target variables, namely, output data. Therefore, the proximity and similarity among data are calculated to divide the data into groups, and the relationships between data are estimated. Typical examples include logic for making recommendations in online shopping. Unlike supervised learning and unsupervised learning, no data are available in reinforcement learning at the beginning. The system by itself improves its accuracy through trial and error. For example, consider how to increase the walking distance of a robot. Instead of estimating the walking distance based on the input data, the robot tries new ways of walking by itself to increase the walking distance and finds the best way of walking by learning from the results. The key is learning through trial and error. Both methods are intended to consider inputs, to correctly predict the future with the factors of change, and to maximize outcomes using the results. By creating models that can be used to predict the future correctly with machine learning, it is possible to develop marketing strategies to maximize sales and devise measures to optimize production processes at plants and delivery routes outside the plants. Machine learning has been widely used in business fields as well. To understand machine learning, it is important to understand how it differs from statistics. Machine learning is literally about machines that learn automatically, whereas statistics is about making statistical decisions on rules and patterns of data. These days, it is common to use computers in the world of statistics as well, which makes it difficult to draw a clear line between the two. Some say that statistics and machine learning are not quite different, others say machine learning is an applied version of statistics, and still others say machine learning is statistics excluding models and hypothesis testing. It can be said that there are no clearly defined relationships between the two. Statistics and machine learning are common in that they are used to find rules and patterns in data and build models. It is often said that the difference is the purpose, not the data analysis method. The main purpose of statistics is to describe data, while the purpose of machine learning is to make a prediction. Statistics can also be used to make predictions by using regression models. Statistics focuses more on better explaining the rules behind data, whereas machine learning is more concerned with predicting them better. In statistics, many models are composed of explanatory variables that can be understood intuitively, whereas machine learning also considers explanatory variables that cannot be understood intuitively. Therefore, machine learning may produce results that are more accurate. This is why machine learning is said to be compatible with big data.